Hello, welcome to our video for lesson 2.3. This video is mostly on logarithmic functions, but in order to get there, we need to review what we talked about in 2.1 and 2.2, and that was the exponential functions. So remember, we were solving equations in this exponential form, f of x equals b to the x power. Remember, b is called the base, right? The base of the exponential function raised to the exponential or the exponent. This is also a form. It can be multiplied by some number as well. So that's just a. This is multiplied times b to the x. So you might say something like that. What we're going to look at today is logarithmic functions, and they're what's called the inverse of exponential functions. And you talked about this term inverse in Algebra 2, and that's essentially when you switch the x and y points or the x and y terms on a graph. And we're not going to go through again how to find the inverses. We're going to look at sort of this relationship with exponential and logarithmics. Okay? And so these are new. Okay? They're totally new. You're going to need to spend some time sort of figuring this out, processing this a little bit in your head. So that you'll be able to apply it when we do the problems, okay? So, this is the form of a logarithmic function. F of x equals log base b of x, okay? See it over here? This is how it's read, log base b of x. And again, f of x is the same as y, right? So, usually you're going to see it in this y form. And so, when you see this, the b is subscript, okay? It's below the log and the x. The log and the x are on the same level. Nope, that does not say same. Are on the same level, and then the b is sort of a subscript. It's below the log and the x, okay? And the y. The y is on the same level as the y and the log and the x. And so there's three types of functions, and so you're going to need to know these three. They're pretty simple once you just sort of work with them a little bit, but three types. The first one is where there's any base. B, so here's b, b's our base, right? Log base b of x. B is any positive number, okay? So I can put any number in here. 2, 3, 1/2, 17 million, right? You're not going to see numbers that big, but anything that's positive. Common logarithms are logarithms with a base of 10, okay? And so what that means is you have y, I'm going to do this in a different color, y equals log base 10 of x, okay? And really, when this happens, when there's a 10, you're not going to see this 10. It's going to be invisible. So it's just going to look like y equals log of x, okay? And when it looks like this, it doesn't mean that there's no base. There is a base. It's just invisible, and the b, right, in our form here is a 10. So these two are sort of the same idea. And the natural logarithm is a logarithm with a base of e, okay? Don't freak out. What's e? I don't know. E is sort of like pi. It's an irrational number that goes on forever. And really, we're not going to use it much. You're going to be able to plug it in on your calculator. So e is essentially 2.71 something, and then it goes on to forever. But this is like the 3.14 of pi, the approximation. So it's 2.71. And it's sort of the natural base in logarithms. And so when we have this is y equals log base e of x. And remember, e is a number, it's not a variable. Except you're almost never going to see this log base e, okay? Same way as log base 10 just went to this. The log base e turns into y equals ln of x, okay? And so log base e essentially is the same thing as ln. And so this is what's called the natural log, ln, okay? And these two are the ones that are on your calculator. If you take a look at your calculator, and we'll review this a little in class because we haven't looked at calculators before. We haven't looked at calculators, we haven't looked at logarithms on calculators. And there's two buttons on your calculators. There's ln and there's log, and those are just using 2 and 3. So ones like number 1 you can't just put into your calculator. So these are really the ones that we're going to be working with. Okay. So let's again pause this, rewind if you want to talk through this a little more. I know this form's a little bit confusing. We're going to look at how to get this though, and so we're going to look at how to switch from logarithmic to exponential and back and forth. So again, we have f of x equals b to the x and log base b of x. Okay. Alright, so when we are changing from logarithmic to exponential or back and forth, remember this double arrow from geometry, it's a biconditional, right? You can go one way or the other. And essentially this is the rule here. So there's a logarithmic function in the form y equals log base b of x, and then an exponential function in the form b to the y equals x. Okay, and so what happens here really is these letters are the same. Okay, the log disappears when you turn into exponential form. There's no more log. Okay, the b is the same b as here. These are both the bases. Remember in exponential form, b to the y, right? And you'll notice that the y and the x switched from the way that I have it written here. Okay, but it doesn't matter. They're interchangeable, okay, when we're switching from one to the other. So I always remember to start with the b, right? So here's the base, here's the base. So the base turns into the base of the exponential, okay? The exponent's the y, and that's what it equals to over here. So the base raised to the y exponent, which is what it's equal to, equals the term that's on the same level as the log, okay? So the base, I start with the base, then there's the exponent, which is what it's equal to, and then it equals over here into the x. Okay, so I know this is tricky. I'm going to go through 4 examples. The first two are switching from logarithmic. You'll notice there's logs here, right, into exponential. And then the second two are in exponential and changing it into logarithmic. I think it's much harder to do these bottom two. So we're going to look at the first two first. Okay, so remember, these are both in logarithmic. If it's in logarithmic, I'm going from here to here. So I want to take away this log. I don't want it anymore. And so remember where I said to start. We're going to start at the base, right? So my base in this equation is 18. Right? 18. So that's what this b is. And then the exponent is y, which in my logarithmic forms is what it equals to. Well, what it equals to here is the 2, right? So 2 becomes my exponent. This comes up here. My base comes here. And so then that equals x. X was the term on the same level as log, and so that's my 324. Okay? And it doesn't say to evaluate, all it says is rewrite, and so here is this in exponential form, and that's it. This is just practicing going from one to the other. Okay? So, same thing here. I start with my base. My base is 7. I raise it to y. Y is what this in logarithmic equals to, so 7 to the y power equals what's on the same level as log is the x. So the x comes here. Okay, so again, base 7 to the y equals x. And it follows that pattern every time. 18 to the second equals 324. Okay? Alright, going from logarithmic to, exponential to logarithmic, I find a little bit more challenging, but that's alright. We can still do this. We again are going to start with our base, right? We want this now in logarithmic form, so I know there's going to be a log. And that doesn't look that great. Okay? So right now it's in exponential. I want to change it to logarithmic. So log base b. Alright, so well again, what's my base here? My base is 15, right? So that's 15. And remember, that's below, right? That's subscript. The base is below in logs. And then the x is in my exponential form what it's equal to here. That's 225, right? Because this is an exponential form. So the x, what I want to put next to the log base, is what's equal to an exponential. So log base 15 of 225, and that's on the same level as log. It's not an exponent, okay? Equals, and equals y. Well, y here was the exponent, right? And so that's 2. Okay, same thing over here. I know I want it in logarithmic, so I'm going to have a log. But what's my base? My base here is 12, and that's subscript, that's below. And then I want next to the log x, which over here in exponential is what it equals to, so that's 37, which equals the exponent, right? The exponent, I'm sorry, here we're in logarithmic, the y, which was the exponent here, so here that equals to x. Okay, again, it doesn't say evaluate, just rewrite. Okay, so if you need to, again, go back, look through that review. Let's try a few more examples here. Because I know it's a little bit tricky. Again, we'll go through some of these in class. Let's try this color. So you'll notice here that I put in here, again, same directions, rewrite as an exponential, okay? And what I don't have here is an equation, right? I don't have an equal sign. So I'm going to write this just equal to x, because I don't know what it equals to. And look at that, you know, that actually works out for all of these, because none of them are equations. Oh my gosh. Okay. Equals x. Alright, so rewrite as an exponential function, and then these two actually say evaluate. Alright, so this right now is in logarithmic, rewrite as exponential. We remember our rule from the last part, the last slide. Right, so we take our b to the y equals x, b to the y equals x. So these are both in logarithmic already, so we're changing from here to here. So we start with our base. Our base here, oh, what is our base here? That's a good question. Remember what we said on that first slide? If there is no base, it's assumed to be an invisible 10, right? So this is 10 to the x power, because 10's our base. This, what it equals to, becomes the exponent, equals what's on the same level as log. That's 11. Okay. How about number 6 here? ln, right? ln is the natural log. Oh, you know what? This is the common log. Should have said that before. Go back and take a look at that. That was the second type that I gave you. Natural log's the third type, ln. And so remember, this has a base of e, right? And so this turns into e is my base, x is my exponent, equals 67. Okay? Just says rewrite. So then, and this is what we're going to be looking at more, and these two are pretty simple, hopefully, that I gave you, just to point some of these out. Evaluate means actually find an answer, okay? So I plugged it equal to x. In order to evaluate, I need to change into exponential. Oh my gosh. I need to type this out maybe. That would work better. What's wrong with me? Maybe it's cursive. It doesn't like cursive. These are the inner thoughts of Ms. Schulte. I hope you're enjoying them. Alright, I need to change into exponential form in order to solve. So, same thing we were doing here. I have 7 to the x power equals, oh man, I'm about to lose it. Just kidding. Fine. 7 to the x power equals 49. Hopefully this looks familiar to you. This is an exponential equation, which we did in 2.1 and 2.2, right? We've already worked on these. And so in order to solve these, remember I need the same base, and I can only change them with exponents. So 7 to the x, and I want to change it to the smaller one, right? So 749, well, hopefully you're all noticing 49, I know, is 7 squared, right? So 7 to the x equals 7 squared. Okay. Now they have the same base, and so I know their exponents are equal, and so we know x equals 2. No, that's not a 2. Okay. And there's our answer. Okay. Same thing here. Evaluate. I have 4 as my base to the x power equals 1 over 16. Well, hopefully you remember from, again, 2.1 and 2.2, I have this fraction, right? And so in order to make it into the same base, I'm going to have to change this fraction into a negative exponent. Hopefully, again, you notice 4 and 16. 16 can change into 4 squared, right? So this gives me 4 to the x equals 1 over 4 squared. But they're still not the same. I need to move this to the numerator, right? And in order to do that, this exponent's going to change signs, and so it changes negative. So I have 4 to the x equals 4 to the negative second. And now they have the same base, and so x equals negative 2. Okay? Alright, I know this is new stuff. We'll practice it in class. But please, please, please try to think through this, look through it, and pay attention to sort of what you're confused on and what we can talk about in class. Here are the dice for today. Add these up, put them in on your CPP. Alright, see ya in class.